This video is sponsored by Cycoil. Hi, I'm Miles Budimir with Design World Magazine, and we're here with another installment in our Motion Control Basics series. This time we're talking about flexible cables and flexible cabling. Flexible cables, or continuous flex cables, are specially designed to cope with the tight bending radii and physical stress associated with motion control applications. A higher level of flexibility translates into an increase in service life for a cable inside a cable carrier. A regular cable typically manages 50,000 cycles, but a flexible cable can easily handle between 1 and 3 million cycles. Flexible cables can be divided into two types: those with conductors stranded in layers inside the cable, and those that have bundled or braided conductors. Stranding in layers is easier to produce, and therefore usually less expensive. The cable cores are stranded firmly and left relatively long in several layers around the center, and then enclosed in an extruded tube-shaped jacket. In the case of shielded cables, the cores are wrapped up with fleece or foils. However, this type of construction means that during the bending process, the inner radius compresses and the outer radius stretches as the cable core moves. This can work quite well because the elasticity of the materials is still sufficient, but material fatigue can set in and cause permanent deformations. The cores move and begin to make their own compressing and stretching zones, which can lead to a corkscrew shape and ultimately core rupture. The other construction technique involves braiding conductors around a tension-proof center instead of layering them. Eliminating multi-layers guarantees a uniform bend radius across each conductor. At any point where the cable flexes, the path of any core moves quickly from the inside to the outside of the cable. The result is that no single core compresses near the inside of the bend or stretches near the outside of the bend, which reduces overall stresses. An outer jacket is still required to prevent the cores untwisting. A pressure-filled jacket fills all the gussets around the cores and ensures that the cores can't untwist. The resulting flexible cable is often stiffer than a standard cable, but lasts longer in applications where it must constantly flex. Selecting the right flexible cable for an application starts with a few fundamental parameters. First, determine the application type. Will the cable be stationary or will it be moving? If the latter, is the motion mainly flexing, or is there any torsional motion involved? Or does the application call for both flexing and torsion? Different applications have specifically designed cables for that type of application. Next, consider the wiring itself. That is, the number of conductors needed, the size of the conductors, and the operating voltage. Also, are there any special insulation or jacket materials required, or any special shielding requirements? And don't forget to check for any special approvals that may be required, such as UL, CSA, or CE, or others. The environmental conditions in which the cable will operate are also important in the selection process. For instance, what is the operating temperature for the application? Will the cables be in low temperature, freezing, and below freezing, or high temperature environments? Also, will the cables need to be oil resistant? In this case, there are cables that provide minimal protection, which may be sufficient for low-level exposure, and cables that provide full immersion protection over a period of days. Lastly, consider flame resistance. Options can range from minimal protection to higher levels of protection depending on the needs of the application.